Hey guys, today we're going to be talking a little bit about constant velocity, which we have been discussing for a while now graphically. We're going to start moving into the more mathematical side of that. But first up, you got to know a little bit of vocabulary. And these were in your first day of school, motion vocabulary, but we're going to go over them again just to make sure you remember. First up is scalar. A scalar is a numerical quantity that has a magnitude or a number, but it doesn't have an associated direction. And it can have a unit. Unit is fine, but it just doesn't have a direction. An example of this is something like mass. Mass is just a number. You could have something that has a mass of 30 kilograms, but that doesn't have a direction. It's just a property of the matter. So it's a scalar. It's a numerical quantity, has a size, but it does not have a direction. And that's opposed to a vector. A vector is a numerical quantity that has magnitude and direction. So a good example of this is velocity, which we've been talking about. So velocity is like your speed, but it's your speed in a specific direction. So it would be like you running 8 meters per second. You can't run 8 meters per second, but say if you could, like you're Usain Bolt fast. If you could run 8 meters per second, to make that a velocity, it would have to be 8 meters per second in a specific direction. So like running 8 meters per second north would be a velocity. Next word we have is rate. So rate means how much something changes over time. In the context of physics, it means how much something changes over time. So a rate of motion is like a speed. Electrical current is a rate. It's how much charge moves past over a certain amount of time. Acceleration is a rate. It's how much your velocity changes over time. So it's just some sort of change happening over a certain period of time. Next up is the difference between speed and velocity. Speed is a scalar quantity, whereas velocity is a vector quantity. You get speed is scalar, velocity is vector. Easy to remember because they have the same first letter. But if speed is a scalar, that means it's a numerical quantity with a magnitude or size, but no direction. And speed describes how fast something is going, but not in a specific direction. That could be in any direction. So an example of this is if you're moving 8 meters per second. You say you can move 8 meters per second. But a velocity is a vector. It describes the rate of motion in a specific direction. So you could have 8 meters per second going north. And that would be a vector. So it's a velocity. Another kind of weird thing that happens with speed and velocity is that speed is defined as distance over time. We talked about distance a long time ago. Distance is a path length. So say you run around a track. Here's going to be my very poorly drawn track. Say you run around the track. You start here at the beginning. You run all the way around, do the 400 meters, and you get back to the same spot. The distance you ran was 400 meters. It's what your body actually felt. It is the path length that you traveled regardless of where you started and ended. It is the total path length. And to get speed, you have that distance over time. And it's a scalar because that distance didn't necessarily have one direction. You could see you turned and changed directions. But velocity is displacement over time. Displacement over time. So what happens is when you run around the track, your distance is 400, how long your path length was, but your displacement is how far you ended up from where you started. So if you start and end at the same position, your displacement is just 0. So a velocity is related to displacement over time, whereas speed is related to distance over time. And the velocity has a direction because if you start at one place, say we start here and end at another, there is a very specific straight line direction between those 2 points, and that's the direction associated with your velocity. All right, so now on to the actual notes part besides vocabulary. We know that velocity is describing a rate of motion, and motion is just a change in position. So velocity could be defined as the rate of change of position, or how much position is changing over time. And if you put that in mathematical form, you get something that looks like this. You will get that velocity, which is going to be a v, a lowercase v actually, even though mine is very large. Velocity equals delta x, that's the Greek letter delta, and it means change. So velocity is change in position. Sorry, I can't speak. Change in position. So delta for change, x for position, over change in time, which is delta t. So velocity tells us how much our position changes over time. And it's going to include in that a direction between the start point and the end point. But today we're not going to worry too much about direction. We're just going to be working with the numbers for a little bit before we start adding direction in there as being super important, even though it is super important. And to solve these problems involving a constant velocity, which means a velocity that doesn't change, we're going to be using the guess method. Now, if you have taken IPC, you'll be very familiar with the guess method. Also, if you've taken our chemistry class, we've done a little bit of guess method in there. And really, it's the I guess method. So I guess stands for image, which is just going to be picture. G for givens, where you write down all your given information. U for unknown. E for equation. S for substitution. And S for solution. We're going to start off with this example problem over constant velocity. I'm working our way through that I guess method. Our question says, if an unladen swallow can fly 50 meters in 4.6 seconds, what is the airspeed velocity of an unladen swallow? We're going to assume it doesn't matter if it's an African or a European swallow, just for those of you who understand this reference. Now, to start off with the I guess method, we have I for image. And for image, we're going to be doing some graphs like we did last week. And it says, if an unladen swallow can fly 50 meters in 4.6 seconds, what is the airspeed velocity of an unladen swallow? And we're going to assume a constant velocity. So in constant velocity, our position time graph is going to be straight lined, because a straight line means constant velocity for position time graph. And by straight line, I mean straight constant slope, not horizontal necessarily. Now it says the unladen swallow can fly 50 meters in 4.6 seconds. So we're going to start our unladen swallow at 0, and it's going to fly for a little bit. That's showing motion. How far does it fly and how long does it take? It takes 4.6 seconds, which is time. So it'll go on the x-axis. And then it flew 50 meters, which goes on the position axis or the y-axis here, going vertically. So it goes 15 meters in 4.6 seconds. And our velocity time graph is just going to look flat because its velocity is going to be constant. And we're going to make it in the positive direction. And that's all there is to the I part of I guess. Then we get to the G, which is givens. So we need to look at the given information in the question. The first piece of given information you run across is that the unladen swallow can fly 50 meters. Now, 50 meters is talking about a change in position or a displacement flown. So it's going to fly 50 meters as delta x. And it takes 4.6 seconds for the swallow to do so. So delta t, the amount of time that has passed while it flew 50 meters, is 4.6 seconds. Those are our two given pieces of information. The question asks, what is the airspeed velocity? Velocity. And that's our U, our unknown. Velocity is question mark. So we've done image, we've done givens, we've done unknown. Now we're on to equation. Our equation was written earlier. It is that velocity equals delta x over delta t. Now when you write your equation down, we're going to be using the same equation all day. You need to make sure it's solved for the correct variable or the thing you're looking for. You are looking for velocity and it is solved for velocity, so everything's perfectly good with this one. But later on that step will become important. This S is for substitution, which is where we plug in numbers. Velocity doesn't have a number yet. It's our question mark, so we leave it alone. Velocity equals delta x. The number for delta x was 50 meters, divided by the number for delta t, which is 4.6. And I shockingly forgot to put it down. Our unit there, it's 4.6 seconds. So now all you got to do is 50 divided by 4.8. Or sorry, not 4.8, 4.6. And my calculator tells me that 50 divided by 4.6 is 10.87. Now, you may not know the unit for velocity. There could be miles per hour, there could be meters per second, there could be feet per second, there could be kilometers per hour. There's lots of different possible units. So you'll be able to know your units, mostly because we use the same ones all the time in this class. But you can also find it from the actual math that you did. When you do math with numbers, you're also doing math with units, even though most of the time you don't pay attention to it. So we did 50 divided by 4.6 to get this number. In order to get the unit, you do the same thing with our leftover units. To get the unit for velocity, you take meters and divide it by seconds to get meters per second. So our velocity here is 10.87 meters per second. All right, I want you to try this next one with me, and then I'll let you do number 3 on your own, and then I'll put up the answer so you can check it. But number 2 is going to be slightly different. It says, if you travel at a constant velocity of 97 kilometers per hour, which is about 60 miles per hour, how many kilometers can you travel in 3.2 hours? Now we're going to do our position time graph. It says constant velocity, so it's going to be a straight line like that. How far did we go and how long did it take? Well, we're not quite sure yet. We did travel for 3.2 hours. We know the time. And we know the constant velocity is 97 kilometers per hour, which is the slope. So the slope will be 97 kilometers per hour. Now our velocity time graph, if it's constant velocity, is just going to be a straight line, constant velocity. Now we get to the rest of the I guess method. That was the I. Now we're at the G, which is givens. Our givens are 97 kilometers per hour, which is about 60 miles per hour. We don't actually need that information. It asks how many kilometers we can travel in 3.2 hours. So our 97 kilometers per hour is a velocity, and our 3.2 hours is a time. And the question asks how many kilometers can you travel in 3.2 hours? How many kilometers is talking about delta x, how far we can go, our change in position. And that's the question mark here. And then our equation is velocity equals delta x over delta t. And here's where the trouble comes in. We are solving this for delta x, which is not what the equation is solved for. So we're going to have to do a small bit of algebra in order to solve for delta x. In order to do that, we have to get delta x by itself. So we need to get delta t away. Right now we're dividing by delta t. So to get it out of there, we have to multiply by delta t. And they cancel out. But what you do to one side, you have to do to the other. So you get a new equation that says delta x equals velocity times delta t, which we can substitute for. Delta x, we leave alone because we don't know the number for it, equals velocity, 97 kilometers divided by hours, or kilometers per hour, times 3.2 hours. And here's where units becomes important again. You can do 97 times 3.2, and you'll get 310.4. But are you talking about meters? Are you talking about miles? Are you talking about inches? What are we talking about? Well, let's figure it out. We once again have to do a little bit of math with the units. If you take kilometers per hour and multiply them by hours, hours and hours is going to cancel out. So our 310.4 is in kilometers. All right, last question. I want you to try this one all on your own. What I'm going to do is in a second, I'll ask you to pause the video, and then I'll pause my recording. I'll write everything out, and then you can check your answer with that. But after I have you pause to do this problem on your own, I'm then going to show the algebra and then pause again and show the answer. So that's what's coming up. Go ahead and pause the video. Try to figure out this problem. All right, here's the algebraic bit. We're starting with velocity equals delta x over delta t. And we're trying to solve this for delta t. To solve for delta t, you've got to get it out of the denominator because you can't solve for something that's in the denominator. So to solve this, you have to multiply each side by delta t. And get delta x equals velocity times delta t. Which is still not solved for the right thing, but at least everything's on top. Last step is to get v out of the side with delta t. So divide by v on both sides, and you get delta t equals delta x over v as our new equation. And we're going to substitute for that. I'm going to pause the video and fill out the rest, and you can see if you get it right. All right, and the answer I get is 32.2 seconds. As the total run time for Usain Bolt to run the 400, given that he's running constantly at his top speed. All right, go to Google Classroom and try to work on the practice. If you have any questions, let me know. My office hours did get canceled this week because of Martin Luther King Day. So if you really need that office hour time and you didn't get it because of the holiday, please email me and we can set up some other time.